Dear students, in this online video session, talk about operating system level virtualization and middleware level virtualization concepts. So let us discuss those topics with a PowerPoint presentation. What is virtualization? How virtualization is important operating system level, and how middleware technology supports for virtualization. We'll talk in this video lecture. These two topics we'll discuss now: virtualization support at the operating system level and middleware support for virtualization. These two topics we'll discuss now. So the levels of virtualization implementation and virtual machine monitor, design requirements and providers discussed in earlier class. Now let us move to the topic now. Here, question is how a traditional computer will differ with virtual machine computer. Why we need to move or convert a traditional computer into virtual machine computer? At what situations or what scenarios we need to use virtual machines? We'll talk about now. If you consider a traditional computer system or a desktop system, it seems to be the computer is working with a single operating system. The single operating system can control a set of hardware resources like hard disk, some input devices, keyboard, mouse, graphics card, memory card, and processors. These physical hardware components, which can be controlled by a standard operating system like Microsoft Windows or Linux operating system platform. So all the hardware components which are integrated together, and these hardware components are controlled by one operating system. The operating system having many application softwares which are internally installed. If we performed any task in computer or desktop system, that can be done with the help of application software. If you want to use or if you want to run any application software, you need one operating system environment for executing the task. So any number of application softwares can be executed simultaneously in an operating system environment. So this entire setup is considered as a traditional computer, traditional desktop system. Here there is no virtual machine at all. Everything is actual. Nothing is created here. Next, we move to virtual machine. What is virtual machine? We will move to discuss here. Virtual means that, what is virtual? Virtual means that something created new, not actual. Created an new, not actual. Virtual means not actual. Something created new. Can be visible or seems to be a single computer, but internally many functionals are carried out. That is called as a virtual machines. If you consider a graph here, a diagram here, the virtual machine with virtual machines means, so here physical hardware devices which are controlled by an operating system, that is called virtual machine monitor. What is virtual machine monitor? This is a new layer which will be kept in middle or top of the hardware. A new layer of a software will monitor the complete functionality of the virtual machine. So here, once the hardware components are integrated in a system, the hardware components can be controlled by an operating system. Operating system having one virtual machine monitor or a server which is installed over the operating system. Once the virtualized software installed in the operating system, with the help of virtual machine monitor, we can create two or more virtual machines on the top of the operating system, namely virtual machine 0 to virtual machine 1. So the virtual machine 0 here also a newly created virtual machine that can be generated. It can function just like a human computer, and many human computers which are running over the operating system with two or more guest operating systems. So with the virtual machine technology, more than two operating systems, different operating systems or multiple operating systems, and share the hardware resources at that time. So that's why we can utilize, or that's why cloud computing is very familiar with the working of virtual machines nowadays. What are various types of virtualizations we'll discuss now? There are three well familiar virtualization concepts. The first one is full virtualization. Second one, para virtualization. And third one, operating system level virtualization. So these three are well familiar server-side virtualization concepts. So based on our requirement, the resource allocation will depends on these three: full versus para versus operating system virtualization. Let us see the difference of full versus para versus operating system level virtualization in detail in the next slide. Now here we will compare various types of virtualization. Three virtualizations will be visible here. Let us consider the first one is full virtualization. Full virtualization best example is Microsoft and parallel systems. It is having less security, but it can allow multiple guest operating systems to execute on host operating systems independently. So let us consider the full virtualization. So in that, hardware components which are controlled by host operating system. In that host operating system, install the virtualization software. The virtualization software name is hypervisor. Once the virtualization software installed in your local operating system, then only we have a privilegation of creating virtualized virtualized in operating systems over here. Here there are two different types of virtualized operating systems which are generated are running with guest operating systems, and the guest operating systems can be installed with various applications here. So two different operating systems which are running at the same time with the help of the virtualization software, which can be hosted on the whole operating system with the help of the same hardware resources. That is called as a full virtualization. In full virtualization, machine allows multiple guest operating systems to execute on host operating system independently. Next, move to para-virtualization. In this para-virtualization, if you compare the para-virtualization concept with full virtualization concept, here the modified guest operating systems will be generated. Here, the modified operating systems will be generated. The best example for this para virtualization is VMware. VMware is one of the best example, and Gen servers, XEN, Gen servers is also one of the familiar servers which can be supports for para virtualization. So it is more secure compared to the full virtualization. The para virtualizations are well secured when compared with the full virtualization. This para virtualization machines allows multiple modified operating systems to run on a host system while communicating. While communicating, if you observe these two, only the difference is it allows multiple guest operating system. It is not allowed multiple operating systems, guest operating system. This is the main difference between these two. Next, move to another one is operating system level virtualization. This is one of the familiar virtualization concepts. Operating system level virtualization. So begin having sharing the hardware resources. These hardware resources can be controlled by host operating system, and here we are not installed any virtualization software here, but it can provide an environment to kept two or more virtualization environments in the host operating system with the help of various library files and bin files. These library files and bin files is having the autonomic body, their work with their own privilegizations with the help of the application software. Next, we will discuss the difference between full virtualization with the para virtualization here. So the full virtualization is a computer system, a common cost-effective type of virtualization in which computer service requests are separated from the physical hardware systems that facilitate in the full virtualization machine. The full virtualization machine allows the guest operating systems to execute independently, and the guest operating systems issues or hardware calls to access the hardware, and it is having less secure and performance is very less if we use virtualization. When we use para virtualization, it is a virtualization technology in which modified guest operating systems is recompiled prior to the installation of inside a virtual machine. Inside the virtual machine, it allows modified guest operating systems to communicate with the hypervisor. Hypervisor is considered as a, it is one of the virtualization software. It is one of the virtualization software which can be allowed to create 2 or 3 virtual machines modified operating system with application softwares. Guest operating system directly communicate with the hypervisors with the help of required drivers. So it is having more secure compared to the full virtualization, and best example is VMware and Gen servers are best examples for this. Now we will broadly discuss about what is full virtualization, what are the advantages and limitations will listed over here. A full virtualization machine, in this we are having maintaining 2 different guest operating systems that are unaware each other. These two work independently. There is no communication among these two guest operating system in full virtualization manner. So the full virtualization provides support for unmodified guest operating systems. Here, system will run with guest operating system, not run with unmodified operating systems. That means that there is no privilegation of modified the existing operating system when we utilize the services of full virtualization. So here, one of the well familiar hypervisor or virtual machine manager or software. This will control the entire virtual machine. So this is a software for creating a virtual machine which directly interact with the hardware such as disk and CPU or x86 hardware. This is one of the familiar server. The hypervisor software allows to run multiple guest operating systems on the host operating system at a time. So here each guest server run on its own operating system. Some of the few examples of full virtualization of virtualization system is Oracle. The Oracle is one of the familiar software company or IT company which can develop the virtualization software, namely virtual box or virtual machine where VMware software and a Microsoft virtual PC. These are well familiar, well developed virtual machines available in the market. So, a few full virtualization advantages will be listed over here. This type of virtualization provides best isolation and security for virtual machines. As we said, there is less security compared to the para virtualization concept. Truly isolated multiple guest operating systems can run simultaneously on the same hardware. So the same hardware, if we utilized for running multiple operating system, so that's why cost also one of the factor, cost consumption. So it only options that it requires no hardware and no virtualization sensitive privilegation instructions to run the full virtualization concept. So some of the limitations listed here running with full virtualization or full virtualization is usually a bit slower. The performance is very low when compared to the para virtualization because of all emulation only. Next, what is para-virtualization and what are various advantages and limitations we'll discuss over here. As we said that there is more security and more performance will occur when you utilize para-virtualization instead of full virtualizations. These are familiar operating advantages of para-virtualization. Para-virtualization is a guest operating system. So here the operating system is a modified guest operating systems. These can directly communicate with each other with the help of the one of the software virtualization that is called as a hypervisor or virtual machine monitor or manager. So this is a efficient virtualization technique when compared with the full virtualization. It allows users to make use of new modified device drivers, and the para virtualization is not like a full virtualization. It allows modified guest operating systems which can have a communication with each other. So here the software virtualization software named the hypervisor, it does not need large amount of processing power to manage the guest modified guest operating systems. The entire system works as a single unit only. It seems to be a single server only. Some of the limitations of para virtualization listed here. The para virtualization requires the guest operating system modified in order to interact with the para virtualization API application programming interface. It requires significant and maintainability issues in the production environments, and it is one of the familiar para virtualization technique. Next, we move to operating system level virtualization. What is OS level virtualization? So, operating system level virtualization, why we use this type of virtualization, we'll discuss now. So, nowadays, one of the familiar technology is cloud computing. The cloud computing is transforming various computing techniques by utilizing the services of hardware components and the staffing the cost of managing a computational center to the third parties, just like a bank. Suppose, for example, let us consider an example of a banking sectors. Nowadays, the banking sectors are daily doing various transactions to perform their tasks to reach their targets. So for that, they can approach the services of cloud computing. So various cloud providers are well familiar nowadays. They are providing the cloud services to the banking sectors. The banking sectors are very effectively utilizing the cloud computing techniques, and just like a hardware and staffing. So if banking sectors will interact with the cloud computing, simply they can connect their server to the cloud, and they can act as a platform as a services, and they can utilize the services as a hardware as a services. The first is the ability to use a variable number of physical machines and virtual machines instances depending on the need of a problem. So when we use virtual machines, we discuss later. Take a simple examples. Sometimes you may work with a single operating system with a single CPU during the execution. Sometimes you need to work with various multiple operating systems or multiple CPUs at the same time. So in this scenario, you need to work with a different operating system. Sometimes you need to work with a single operating system. Sometimes, so based on that demand and supply, automatically, so the cloud computing will sync together and it can provide the services. Go for virtualization concepts. If the virtualization concepts will come into the picture, the single computer will be converted into a virtualized computer. It can run with two or more operating systems, so to perform the task very, very easily. So the second challenge, one of the challenge for operating system level virtualization is it is a slow operation of instantiating new virtual machines. So new virtual machines can be conquered or can be introduced with the help of operating system level virtualization concept only. Next, we will see why virtual level operating system level virtualization is really required nowadays. We'll discuss now. So, in cloud computing environment, thousands of or more than thousands of virtual machines need to be initialized simultaneously. That's why the huge demand in the market virtualization to stand by the market with the help of cloud computing. We need to initiate virtualization concept into the market. So once the virtualization concept launched into the market, the computer system can act as a virtual machine system running with more than two different operating systems by sharing the common hardware resources with the help of the one virtualized software called hypervised. So, moreover, full virtualization at the hardware level also has the disadvantage. So, why? Because a full virtualization machine, if you conquered into the market, it is running with two or more different guest operating systems, but it is very slow and low secure when compared to the para virtualization technique as we discussed in the earlier slide now. To reduce the performance and to reduce the low density security to overcome these problems. The hardware level virtualization, even the hardware level components are which are interconnected are controlled by the operating system. So that's why to provide the security level, to increase the security and to increase the performance of full virtualization concept, we need to do some modifications on the operating system level. So once we use modified guest operating systems, once we allow into the virtualized concepts, our full virtualization is automatically converted into para virtualization. Once para virtualization enter into the market, it can lead to increase the performance and provide more security for that. Operating system level virtualization provides a feasible solution for these hardware level virtualization issues. So, operating system virtualization inserts a virtualized layer. So, it can create an automatic virtualization layer inside an operating system to partition the physical machine into two or more virtualized machine running with two or different operating systems. It enables multiple isolation virtual machines within a single operating system like kernels. Kernel is one Unix concept, Unix command. This type of virtual machines is often considered as a virtual execution environment. The virtual execution environment is a software which can provide the environment for a physical system. So from the user's point of view, virtual environments look like a real server, but it means that the virtual environment has its own set of processors. It is having their own set of file system and user accounts, a networking interface, and IP address and routing tables, firewall security feature also. So independently it can work. It seems to be from the user's point of view. So now move to another slide. Here we will discuss about operating system extensions advantage. Sometimes we need to we need to add extensions to our browsers or extension software to our existing operating systems. So what is the main advantage of extensions of operating system is? So if you want to run various application softwares over a period of time in a runtime environment, so some applications may not support for executing the programming concepts. To overcome the problem, those related files, extension files are required or need to be added to the existing operating systems. So one of the familiar advantage of utilization of operating system extension is all OS level virtual machines work on the same physical machine by sharing a single operating system that is called as a kernel only. So we need to go for extensions for a single operating system only, not individual. So virtualization layer, this is the software that can be designed in the way that allows processes in virtual machines to create many resources of the host machine as possible but never modify them. So that means that in a full virtualized machine, there is no concept of modifying the guest operating system. So whatever the operating system we have been created, that can be used effectively without any modifications done in the future also. Some of the few disadvantages of extensions of operating system over listed here. The main disadvantage of OS extension is all virtual machines at operating system level on a single container must have the same kind of guest operating systems. So this is one of the disadvantages. To overcome the problem, we go for utilizing the concepts of modified guest operating system instead of a guest operating system. For example, consider a window operating system. The window operating systems, just like a Windows XP, this is one of the familiar operating system that cannot run a Linux-based file. So, however, the users of cloud computing have various preferences. They may prefer Windows and other Linux operating systems at the same time to perform their task with the help of the cloud computing technique. Therefore, the one of the challenging tasks is they can run different operating systems on the same machine with the help of the virtualization concepts. So in these cases, this is one of the disadvantages operating system extension. And virtualization, how react on the Linux and Windows platform, we'll discuss now. So that means that virtualization means running two or more different operating systems over a single machine is called as a virtual machine. How virtualization will impact on the Windows, how virtualization will impact on the Linux operating systems, we'll discuss now. So the operating system level virtualization systems are Linux based. Most of the operating systems are Linux based. These are not licensed. These are open source softwares which are running on the Linux based operating systems. So the virtualization supports Windows based operating system nowadays. So, but it is still under research stage only. There is no implementation at all still it is under research point of view. So that's why most of the operating system, most of the virtualization systems run with Linux open source system only, operating systems only. So there are some of the familiar operating system tools, namely Linux vServer and Open VZ. These two tools, operating system tools, which can support the Linux platform to run platform-based applications through the virtualizations. So these tools will help for execute for performing various tasks with the help of the virtualization concept. So another tool, one of the familiar tool is that is called FPM. FPM is also one of the familiar operating system tool that can be used in Windows NT platform. Windows NT is one of the server operating system. For that, we use one of the tool called as a FPM, and it is specially developed for Windows network technological server operating system only. So how virtualization will support for Linux platform will discuss here. So the OpenVZ, it is operating system level tool designed for Linux based operating system only, for which we can create by using the OpenVZ virtualization software or tool. So a virtualization environment is created in the existing system running with virtual machines under different guest operating systems. The OpenVZ operating system tool is an open source container based virtualization solution built on the Linux operating system. So these are various supports of virtualization with the different operating systems like Windows and Linux platforms. Now we move to another concept that is called middleware support for virtualization. So as of now, we discussed virtualization support in operating system level. So now we move to middleware support in virtualization. So middleware is a technology which can be used for converting the one language into another language. It can act as a intermediate node and to perform various tasks. So just like a three-tier architecture. In three-tier architecture, there is no direct communication between client machine to the server machine. The communication over client and server through intermediate node only, that is considered as a middleware. One of the familiar of example for middleware technology is CORBA, common object request broker architecture. With the help of this middleware is well familiar nowadays for providing a well connectivity between client and server machine without any operating systems. So here, library level virtualization is used. So this library level virtualization is also known as user level application, and it can be worked with the binary interfaces or API emulations. So binary interfaces means only zeros or ones. When transaction is done, zeros or ones came into the picture, and automatically with the help of the binary interfaces or application programming interface emulation, it can be performed the task. The library level virtualization is used. This type of virtualization can create execution environments for running programs on platform rather than creating virtual machines to run the entire operating systems. So that's why it is one of the familiar middleware operating virtualization concept. So friends, dear students, in this video session, we discussed virtualization levels in operating systems, or operating system levels in virtualizations, and middleware levels virtualization we broadly discussed. And here we discussed different types of virtualizations also, namely full virtualization, para virtualization, and operating system level virtualizations. Their advantages, their limitations also discussed over here, and how virtualization will come supports for Microsoft Windows and Linux operating systems. How middleware virtualization systems will impact, we discussed in this session. Now I am closing the session. Thank you. Thank you, Sumanta.